Hey guys, my name is Leo, and my partner's name is Peter. We are going to do problem number 12. We have to determine if the series converges or diverges. If it converges, we have to find the value. Our series is the sum from 1 to infinity of the quantity 2 over the square root of 2 to the n minus 1. Before we begin, we can simplify the sequence to the square root of 2 to the n minus 1. We will be doing two tests to determine whether the series converges or diverges. I will be doing the ratio test, and Peter will be doing the root test. The ratio test consists of finding L, which is equal to the limit as n approaches infinity of the absolute value of the a's of n plus 1 over the a's of n. Then, if L is less than 1, we can say that the series is absolutely convergent and hence convergent. If L is greater than 1, or if the limit is equal to infinity, then the series is divergent. If L is equal to 1, then the series may be divergent, conditionally convergent, or absolutely convergent. If this is the case, then the ratio test is inconclusive and more tests are needed. First, before we find the limit, we need to find the a's of n plus 1. To do this, we substitute the quantity n plus 1 for every n in our sequence. Therefore, we get the square root of 2 to the n plus 1 minus 1. Simplifying this, we get the square root of 2 to the n. Now we plug these values into the limit, and we get the limit as n approaches infinity of the absolute value of the square root of 2 to the n over the square root of 2 to the n minus 1. Simplifying, we get L is equal to the limit as n approaches infinity of the absolute value of the square root of 2. L then is equal to the square root of 2, which is approximately 1.414. Since L, 1.414, is greater than 1, we can say that the series is divergent by the ratio test. Peter will now show you the root test.
Hi, this is Peter, and I'm going to be doing the root test. For the root test, we need to find the limit as n approaches infinity of the nth root of the absolute value of an. We first plug in our value, which is the square root of 2 raised to the n minus 1, in order to find the limit. For the second step, we take the absolute value of the square root of 2 raised to the n minus 1 out, because the square root of 2 raised to the n minus 1 is positive. We also change the nth root to the power of 1 over n. Do you guys agree with me that it's the same thing as the nth root? Then we say the limit as n approaches infinity of the square root of 2 raised to the 1 minus 1 over n. And now we have the limit as n approaches infinity of the square root of 2 raised to the 1 minus 1 over n. We got 1 minus 1 over n because we multiplied the n minus 1 to the power of 1 over n, and that's how we got that. And now we say the square root of 2 raised to the 1 minus 0. We took the limit out because we plugged in the infinity for n, and we got 1 minus 0. And this gave us the square root of 2, which is approximately 1.414. Now that the answer we got is greater than 1, we say that by the root test that series is divergent.